Hello everybody and welcome to the MLittleProgramming tutorial. Please drop a like on the video as it really helps the channel, and subscribe if you haven't already. Let's get into it. So today we're going to be looking at hooks. What are they, their syntax, and how we can gradually transition to using them in our code. Hooks are a new addition in React 16.8. They are backwards compatible, meaning they'll work alongside existing code. React themselves don't recommend any big rewrites of code, especially complex class components. There are currently no plans to remove class components from React. Instead, we can write hook components alongside our current class components. Furthermore, what's great is that hooks cover all existing use cases for classes. So, what are hooks? Hooks provide a more direct API to React components we already know and use: props, state, context, refs, and lifecycle methods. Hooks also provide powerful new ways to combine them. Hooks let us hook into React state and lifecycle features from functional components. Hooks don't work inside classes, but they allow the use of React without classes. Why should we use hooks? The first reason is more to do with JavaScript than React. To work with classes, a developer has to understand how the this keyword works in JavaScript. The this keyword works differently in React than in other languages, so the pickup time for example, a backend developer could be reduced by using hooks with functional components. In React, it has also been observed that class components do not minify very well, and this sometimes makes hot reloading unreliable. By using functional components with React, you will not have to face this problem, as it seems functional components minify better. React also makes it difficult to reuse stateful component logic. Higher order components and prop render patterns attempt to address this problem. However, the use of higher order components can make the code hard to read for developers new to the codebase. Components end up being wrapped in several other components to share functionality. Hooks help us solve this problem by allowing us to share stateful logic without changing the component hierarchy. React provides a few built-in hooks. React also allows us to create our own hooks that give us the ability to reuse stateful behavior between different components. There are two basic hooks that we're most likely to use in our code: useState and useEffect. useState allows us to add state to a functional component. When the component re-renders, React will preserve the state. useState returns two values: the current state value and the function that lets you update it. Keep this in mind for a moment and I'll explain why that's important. To use useState, we first have to import useState from React. To declare state in a functional component, assign the name of the current value of the state, the name we'll be using to read the state, and the name you wish to call the function to update it within square brackets. This is JavaScript array destructuring syntax, and it allows us to give names to those two values that useState returns: the current value of the state and the function to update the state. So what does calling useState do? It declares what's called a state variable. Our variable is called count, but we could call it anything else, like visible for example if we were creating a draw component. This.state used to provide this functionality, but React functions have no this. So usually variables within functions disappear after the function exits, but state variables are preserved by React. useState has a single argument. This is the initial state value. Unlike with classes, this doesn't have to be an object. The initial state can be just a string or a number, like in this example. We can also get the value of props that are passed into the function to be the initial state. In the example, we are setting the initial state to be the value of the props, but if that's not set, set the initial state to be 0. How do we read the state? As we're setting up state variables, we can actually just reference the name of the variable to read the state. To show React we're referencing a state variable, we place it within curly brackets. This is similar to how we read state in class components, except, as I've mentioned, we don't have the concept of this within function components, and therefore we don't need to write this.state before the name of our state variables. In terms of updating state within functions, we just call the method we created in the declaration earlier. Our method has a singular argument, which is the new updated value of the state that we want to set. In this example, we're just adding 1 to our count state every time a button is clicked. This again is similar to how we would update state in a class component, just without the concept of this. What about lifecycle methods in function components? We can't use lifecycle methods in functions, so React provides a useEffect hook. useEffect tells React to do something post-render. React does it after it's finished updating the DOM. useEffect is called inside the component, so it has direct access to the state variables and props right in the effect. By default, useEffect is run after the first render and after every update. So this will transition our thinking from mounting and updating to effects happening after render. As you can see, this is a lot shorter syntax now we only have one method that covers all post-render actions. Obviously, by having the functionality of mounting and updating in the same method, we could lose some of the performance benefits of conditional rendering in some of our projects. However, useEffect has the solution built right into it. So for example, in component did update, we can compare the previous state and the current state, and if the current state has updated, then re-render. We can't pass the previous state into the useEffect hooks, but what we can do is use this piece of syntax. So between the last curly bracket and the closing bracket, put the name of the state variable you want to compare with its previous state. This will mean the component will only re-render if the state has been updated. Now we've been through the basic built-in hooks, I just want to reinforce a few rules of using hooks. So we should only call them from the top level, so don't call them from inside loops, conditions, or nested functions. By following this, it ensures that hooks are called in the same order each time a component renders. In addition, as I've been mentioning, we can only call hooks from inside function components. To enforce these rules, there is an Eslint plugin. To install the plugin using npm, type npm install Eslint Plugin React Hooks, save dev into your terminal, or if you're using yarn, type yarn install Eslint Plugin React Hooks. After you've installed the plugin, the package.json file in the project you're working on will have something looking like this in it. And that just about wraps up the basics of hooks. What we're going to do now is hop into VSCode and try to add multiple states to both a class component and a functional component that makes use of hooks. So this is your classic React class component. This is the full version of the counter example you've been seeing. So it's a basic React app with a button, and every time the user clicks the button, a counter, which is a piece of state, increases and we output how many times the button has been pressed. This is what the program does. What we're going to do is add a piece of state called button health, which is going to have an initial value, and every time the user clicks the button, the health of the button will decrease by 1. So in a class component, we declare button health within the this.state. Then, when the button is clicked, we want to decrease the health of the button by 1. So we come into this set state and decrease the value of button health by 1. Finally, we want to output that, so we create a p tag to output the value, and we reference the state by calling this.state inside curly brackets. Now let's switch over to a functional component that makes use of React hooks. This has exactly the same functionality as the class component example. Initially, you'll notice that this component is a lot shorter and has the same functionality. As we discussed earlier, to declare the state variables in square brackets, type the name of our state variable, button health, followed by a comma, and then the name of the function we'll use to set state, set button health, and set that equal to useState. We'll pass in 100 to useState, which will be the initial state for our variable. We'll then want to call that function when the user clicks the button. We'll pass the state we want to set as an argument, the current value of button health -1. Finally, we want to output this to the user, and to do this, we'll create a p tag. Type the text we want to output and put the name of the state variable inside curly brackets to read the state. So, as you can see, this is the program working. So if you enjoyed the video, please drop a like down below. If you have any questions, please drop a comment and I will answer it. And subscribe to the channel if you haven't already.